Today I'm going to be talking about one of the products that we developed at Decibel over the last years. And since I've been there for 3 years, I've seen this project from day one. So it's called DXS, which stands for Digital Experience Score. So first of all, let's give a bit of introduction to what digital experience is, because I mean, if you work in web analytics, probably you know it, but if not, just to be sure. So I guess you're all familiar with customer experience. Well, digital experience is the same thing, but it's applied on websites. So these days we use a lot of websites, mobile apps, and sometimes we struggle with them. I don't know if you ever had an issue booking a flight or looking for a train ticket and so on, this kind of thing. So websites think that it's very important to monitor what's going on their basically on their platform, and it's important to get to know how users are basically utilizing these websites and apps. So yeah, it's basically the definition I mentioned there. And as I said, if you think about the behavior, is a digital behavior because it's a digital experience. So we don't talk directly, but we will click. We will scroll on web pages. We will fill forms and submit forms, or trying to. This is basically what we have to deal with to understand the usage of websites. So as I said, it's becoming more and more relevant, and I don't know now the revenue that is based on that, but there's like some companies lose millions because of poor digital experience. So that's why 5 years ago, Decibel, the company I work for, started to think, hey, we should do something more advanced, more ambitious to tackle this problem. So what about using data science? At the end of the day, what do we need to do? We have to measure basically the customer experience in a better way, in a more accurate way. We have some data, so what data do we need to use? How we can use it and why? These are basically the questions. And obviously, are the data we have enough? Should we collect some more stuff and so on? So that's what I'm going to be covering today. So first thing, every business starts with the customer. So what do people want from web analytics? I guess you're familiar with this metaphor. A glass can be seen as half full or half empty. So those who think the customers see the glass as half full, please raise your hand. Those who think they see it as half empty, please raise your hand. Yeah, I guess a lot of you are undecided, which is fair enough. But yes, most of them, they see it as half empty. They want to know what's wrong with the website, why user gets stuck, why this thing doesn't work, why this user did not convert, and so and so. That's what they're looking for. They want to know the frustration of the user so that they can do something about it to fix it. They are less interested in when things go well. It's important, but their main focus is frustration, is struggle. So these are basically the typical questions that we get from customers. So just to get a bit started with web analytics, when I say session, I mean, some of you are probably familiar with it, but just to be sure, it's a visit on a website. So I visit a website, I open a page, the first page, I visit several pages, and then I close the website on my browser, and that's a session. When I say page view, it's the visit of a single page within a website. I'll be using this a lot. That's why I want to make sure everybody understands this, because those are very important metrics, and we use the basic on our job on a daily basis. So when Decibel started, I mean, web analytics was already a thing. There were traditional tools analyzing web analytics. Problem is, they weren't very good at it. So you had, for example, I don't know if you ever used, if you ever build your own website, even like a little blog and so on, and you monitor through, I don't know, Google Analytics or Adobe Analytics in the beginning. It's what you get is people that visit your website, where they come from, which device they use, how much time they spent on the website, and so on, which is interesting, but it's not a lot. It doesn't tell you much about the user experience, does it? So you don't really have much tracking of events, and you don't really know, you can't really build anything with this, or very little. The other method which is used, and is still used these days, is the so-called NPS, the Net Promoter Score, which tells you at the end of a visit of a website, they say, you can spare 2 minutes to fill this survey to tell us if you like the experience or not, what went well, and so on. Yeah, about 90% of people or more don't even take this survey, which limits the data you can collect. The good thing is about experience, but the problem is that those who fill this survey are normally people who are really pissed off with the website, so you collect all the negative feedback. Even if your website is brilliant, you'll have some people who won't be able to go through with it, so you'll have a false impression of your website. That's why NPS are quite limited. So what about using data science instead of just reporting stuff? Think about it. As a company, we have several clients, and we collect lots of data. We collect, these are the estimate I just worked out from the past 7 days. I mean, all the data I'm going to show is coming from production data, so data that we actually collect, and is just a week data, just to give you a reference. We have about more than 5 million sessions a day that we record, and more than 20 million page views a day that we record. So we have a lot of data. We have volume. We have variety because we have, for example, clicks, mouse moves, scrolls, and so on. And we have websites which are very different. They're visited on mobile phones, on tablet, mobile apps, and so on. So we have a good variety of data. So why don't we just start building some model? Just to give some reference for machine learning, this is by definition an unsupervised problem because we can't go and ask every single user how was your experience. So we have to infer something, which is pretty tricky, but we have to try and do it. And also, one of the ideas we had about 3-4 years ago was to say, for every session that we record, we want to report something, either a score or a classification or something. So we want to come up with data for everything that we record. And we thought, yes, then we can do this. So let's start setting up the goals. What I'm going to be telling now is a little bit of a story. So I'm going to take you through the journey I personally took and other people took at Decibel, from starting from there is no really intelligent web analytics to where we are now. So first of all, we want to detect negative experience. It's something I said it before because that's what customers care more about. Then there's the positive experience as well because, hey, why not reporting if we see it? Then we said we want to score every single session, everything that we record on website, because that's what customers care, numbers. And then we want to set up a new metrics, a new indicator of website quality, which is a DXS, which I'm going to be talking about it later. And also, we would like to replace what's currently there, so NPS and other methods, because they don't work really well. I mean, in some cases, you can put it together and integrate it, but normally they don't have much impact. So, okay, we set up the goals. What do we have? What is the starting point? Any JavaScript event that can be collected on website, we tend to capture it as much as possible. So we have timestamps, time events, basically. We have clicks, position of the mouse. We have whenever the position of a page changes due to a scroll, and so on. So we have these metrics. And now, fine, we have it. We can collect them. What do we do? One of the first things that came to our mind as data scientists, as mathematicians, and so on, was to say, why don't we just put these metrics together to aggregate them and maybe derive some more advanced metrics? Like we have position, why do we draw distance? So if a mouse was in this position before and now it's there, we can basically assume that the mouse was moved. And once the mouse was moved and we have a distance, we have time reference, so we can look at something like mouse speed, mouse acceleration, and so on. The same with scrolls. Is the user mostly scrolling down to the page, at the bottom of the page, is scrolling on top of the page? Is the device always on portrait or is it going on landscape as well? So we have this thing, and we can basically detect this. And just to give you some more insights in this, I'm just talking about raw metrics. This is the beginning of the story. This is where we were about 2 or 3 years ago. The mouse speed in time, for example. Now I'm going to be showing some data from real page view for the stuff that we collect so that we can get some ideas of it. So we had mouse speed. Mouse speed, as I said, we derive it from mouse position, time, and so on. On page 1, on the left, you see a certain mouse speed. On the one on the right, you see a second page view mouse speed. Can you get any insights from it? Would you know if you could mention like frustration or satisfaction from this graph?
They're scrolling down faster on the second page, probably.
Scrolling, sorry?
They're probably scrolling up or down faster.
I'm just talking about mouse speed, not scrolling. It's a different thing. Because when you scroll it, you may be clicking on a slider. It's a bit different. This is just about mouse speed. It's probably not a lot here, But if you see there are some peaks, the peaks may refer to in a certain period in time during the page view, there's been some high mouse activity. This could mean that probably there's something going on. You're not supposed to move the mouse very quickly normally, so maybe there is some frustration there. Let's look at mouse direction, which is another metric that we look into. Page 1 versus page 2. Again, we can classify every mouse move into a direction, which is whether they're going up, down, left, right, and so on. Again, page 1, you have the breakdown of mouse move as it follows. On the page 2, you have these ones. What does it tell us? If we look at those, we can see that on page 1, most of the mouse movements were vertical, either up or down. On the other one, it's a bit more diversified. And especially, there seems to be high activity towards the left of the page. If you look at about 13, 16% up left, down left, and not so much up movements. Probably there's a lot of interesting elements on the left-hand side of the page, so the users tend to move the mouse a lot there. That could be food for thought as well. Clicks are also very interesting metrics. On the same page 1 and page view 2, just as a comparison, I check where all the clicks occurred. So you can see the coordinates of the clicks on page 1 and on page 2. In the first one, you don't really see any cluster or so, but on the second one, you do see some cluster. So probably that area of the page indicates something. It could be a link that doesn't work. It could be, I don't know, like a button or something that opens like a navigation bar. It could be a responsive, an interactive element or not. Anyway, this is probably an area of interest because technically you're not supposed to click many times on a single spot. So that's something that you can start to investigate on. And the same with scroll speed. You were mentioning scroll speed before. I just put up a comparison between these two different page views where you can see that in the beginning of page 1, there's a very high scroll speed. I haven't put the direction here, so I don't know if the user is scrolling up or down, but it's scrolling really fast, which is something you're not normally supposed to do on a web page. So that probably indicates impatient, or also a user who knows the website in and out and just quickly scrolls down to the bottom to do the things he's supposed to do. On the other hand, on page 2, you see that in the beginning, the scroll speed is 0, meaning that the user opens the page and does not scroll at all. So it's probably, there's a lot of content on top of the page to engage with. Then there's a bit of scroll, but if you look at the scale, the scroll speed is much lower as well. So it's probably a user who is more engaged with the content, is not very impatient, is gradually checking what's there, or maybe interacting with the website. And then towards the end, there is no scroll anymore. So as if like, OK, I got to the page portion where I'm interested, and I don't have to scroll anymore. So basically, we had a look at the metrics we had. And you may think, yes, that's interesting, but is that enough for customers? Probably not, because you can give them some insights, you can give them some interesting input, but they want to know the solution. Customers tend to be lazy. They want the job done, which also is why they pay for. So we had to say, OK, we have a bunch of metrics. Let's choose the right one, and let's aggregate them. So we can get to understand when we have a good behavior or a bad behavior from a user, something we expect or something we don't expect. Behavior, just again, a definition here before I move on. A behavior for us is a pattern in time of activity which defines a specific experience. So it could be like frustration, it could be struggle, it could be impatience, it could be engagement, but it's limited in time. So it has a start time, it has a duration, and that's limited to that. That's what we call behavior at Decibel. I'm going to mention some examples of behaviors. That's Decibel stuff, so I have to explain it. When we call burstness, I know the name sounds quite funny, but it's the activity of moving the mouse really quickly for a continuous period of time and in an erratic way. This is a behavior you're not really supposed to do because it's not going to trigger any action on your website. So if you're doing it, it's because your chances are that you'll be frustrated or confused. So this, we flag it and we identify it because it defines some important stuff for our metrics. Multi-click is the activity of clicking very quickly on a spot on a website, a bit like something we showed before. And that normally could refer when something goes wrong. However, by looking at session replay, we can also view we can also play basically the replay of the session that we record. We can notice that sometimes continuous click could be related to interactive elements such as carousel of images or slider bars. So it's not necessarily a bad thing. We have to distinguish here. But that came with experience, so it wasn't straight away from the beginning. Scroll engagement is another behavior where we monitor the user scrolling through a content and then engaging with the content, scrolling again, engaging again. It's a typical behavior of somebody reading an article or filling a form on a mobile phone. This is mostly directed to mobile devices. Okay, so we got behaviors. Behaviors are interesting. When we detect them, we flag them, we report them, so you can see how many bird's nest behavior you had this month, how many reading behavior you had this week, and so on. However, there's a problem with behaviors. They are a yes or no entity. This is the typical classification problem. Either a behavior is true or false, which means you may end up with behaviors or no behaviors at all. So if you have a behavior, you can say something about the experience on that specific session. If you don't, there's very little you can say. So are behaviors enough? How often they are occurring? I mean, we have quite a few behaviors. I just mentioned some of them. But let's have a look a bit to some numbers. These are data related to the average data throughout all our clients over a 7 days period. So scroll engagement is quite a frequent behavior. We have one almost in every session, in average. These are the number of behaviors toward the total number of sessions. But bird's nest, for instance, you have to, in average, wait more than 2,000 pages to see one, because it's not very frequent. People don't move their mouse fast very often. So many times we just don't see it. And so if we don't see it, there's not much we can say. So just to give a bit more numbers as well, to see the session which contains behaviors and session with no behaviors, here are the percentage of the sessions on our client's website which contain behaviors broken down by several behaviors. So you can tell that on 99% of sessions, we do not see any bird's nest. On 98% of sessions, we do not see any reading behavior, and so on. The scroll engagement is a bit more frequent, but that's it. So we can assume the behaviors are not enough, because most of our session will still be inconclusive. We still have no information whatsoever. So, and remember, the first goal we had was to flag every single session that we record, to assign a score or a value to every single session. So behaviors are good, but they're not enough. So we said, okay, we need to come up with something else. As I said, behaviors are a classification problem, because either they're present or not. We have to move this into a regression problem. We have to get the metrics for every page view, for every session, and build some sort of formula which will give us a score and which will represent the experience of the user. We call it the pillars. I'm going to get to the pillars in a second. So giving a score is a very nice thing. Everybody loves one number which defines everything. Unfortunately, it's a bit difficult to sum up the experience on a website with one number. So we decided to split it into different aspects of the experience. First of all, engagement, which we want to see how much the user is doing the thing he's supposed to do on a web page. If you have a login page, you're not supposed to spend half an hour trying to log in. 5 seconds are enough. That's fine. If you're reading a long article, maybe 5 seconds are not enough. So I want you to scroll all the way to the bottom. I want you to spend a decent amount of time on every paragraph of the article, and so on. If there's a checkout page, in order to be engaged, you'll be filling in the form, you'll be submitting the form, and you'll have to spend a decent amount of time on it. Frustration. Frustration defines when things go wrong, basically. Whenever a user is lost on a website, is spending too much time on a page, is clicking frantically, he has to rotate his or her device to visualize properly the content, that defines frustration. That's something we don't want to see, but we have to mark it. Then we have a technical aspect, which we call technical experience score, which defines the quality, the technical quality of a single page. So does it take ages to load? Do you get a lot of 404, for example? This does not depend on the user activity. This is not related to the user, but it will affect the user experience, though. Then we got a special score for forms, because we think forms are a bit of a website within a website, if you think about it, because filling a form is very important to do a lot of interaction on websites. So we address it separately with regards to engagement or frustration score. And so we do with navigation. Navigation is the activity of browsing from one web page to the next one. So for instance, if you visit a website to purchase something, you'll be going through, I don't know, a list of product pages. You will add some product to your basket. You will go on checkout. you may have to sign in and so on, and you'll have a confirmation page, hopefully at the end of the process. So that's like a good navigation score. If you need to go back to home page just to log in, probably the navigation is not ideal, and we will flag this because this will affect the user experience. So once we define the pillars, the scores that we want to achieve, we have to come up with, as I said, as a regression problem. So we have to assign a score. We use scale from 0 to 100, but you can use different scale. That's not very important. So we have to use a bunch of metrics to come up with formulas, with equations, with models, which will result in a score. Now, obviously, this is done through machine learning. This has been trained. So we have metric. We will use different metrics for the different pillars. We want the pillars to be as independent as possible from each other so that we can then put it together at a later stage. So we'll be using such thing as time spent on images or number of responsive clicks for engagement. On the other hand, we'll be using change of orientation for frustration score. For technical score, we'll be using metrics such as the time it takes to download the script, the time it takes to render the images on a web page, and so on. Forms will be about abandoning a form, submitting a form, having a submission failed, and so on. And navigation score would be like, as I said, maybe going back to the home page or visiting the same page over and over again because you have to refresh it, for example. That's not good behavior. So because we want to score every session and every page that we've got, we'll be calculating the score for every page views and every session. If we do this, we can come up with average value. So we have 20 million pages collected every day. We have 20 million scores. We can come up with an average for it. We can come up with a trend for it. Say, for example, we have a high engagement on weekends because people tend to book holidays on a weekend if you're a holiday website. On the other hand, you may have a trend for it. So say, towards Christmas, people tend to be more active on e-commerce websites and so on. So it's something that you can when you have Black Friday, you have a lot of technical issues because server will be overloaded. So if you have a score for every single page view and session that we record, you have basically ways of doing this sort of analytics, something that you couldn't do before because it just didn't have this score, it didn't have these tools to use. And then comes the final score because, as I said, everybody wants to have a score, want to have a number for a session and a number for all. So want to rule them all. So, no, sorry, So as I said, we use every pillar to calculate what we call DXS, Digital Experience Score. Every pillar has different weight based on the models that it's been trained on. And every session will have a DXS. We have a score which will sum up all the different aspects of the experience. So I'm going to be concluding showing you the DXS pyramid. This is basically a sum up of the story that we started so far. So we started off with basic metrics like clicks, mouse position, page position, and so on. And then we moved on to what we call derived or advanced metrics, so such as speed, acceleration, focus rate. On top of that, we come up with behaviors, multi-click, reading behavior, rotation behavior. And these were good to identify specific patterns of engagement, confusion, and so on. But they were still not enough to tell the full story. So we had to come up with pillars with score for every aspect of the experience, so engagement, confusion, and so on. And then we come up with the DXS, which is the final score, which is what we present to the client itself. And well, just to conclude, let's not forget about the nice people that develop these tools because we use them a lot and we couldn't do our job without it. So thank you very much, guys. And thank you for your attention.